Section 10.3, problem number 13. Convert the given polar equation to a Cartesian equation. Write in the standard form of a conic, if possible, and identify the conic section represented. So in this case, we have r equals 2 cosine theta. We're going to convert first into Cartesian, and then we're going to write it in a standard form for the conic section. So here is my equation. R equals 2 cosine theta. We know that r cosine theta is equal to x, but here we only have cosine theta. That means we need an r there. So what I'm going to do here, I'm going to multiply both sides of the equation by r. That will give me r squared is equal to 2r cosine theta. We know that x is equal to r cosine theta, and we know that x squared plus y squared is equal to r squared. So with the replacement here, I'm going to say, here's my equation, r squared is x squared plus y squared equals 2 times this side, which is x. Now this is a conic section. We need to make it into the standard form of the conic section. So first of all, I need to make the right-hand side equal to 0. So I'm going to subtract 2x from both sides of the equation. I will have x squared minus 2x plus y squared equals 0. Notice how I put these x terms next to each other. Now, y squared is a complete square. I don't need to do anything about that. For the term x squared minus 2x, I need to complete a square here. So I'm going to take the middle term coefficient, and I'm going to divide it by 2 and then square it and add that number to both sides of the equation. So if I do that, negative 2 divided by 2 is equal to 1. If you square that, you get 1, which means I'm going to add 1 and subtract 1, or add 1 to both sides of the equation. X squared minus 2x plus 1 plus y squared equals 0 plus 1 is equal to 1. So I added 1 to both sides of the equation. This term right here can be factored into x minus 1 all squared plus y squared equals 1. So I factored this term here into x minus 1 all squared because it's a complete square. And this is the standard form. If I wanted to match it to one of these, you will get an ellipse. Basically, if you look at this equation, we just did something similar to that equation, which is representative of an ellipse. So that is going to be the answer. Let me see if I can go back to the question and plug these in here. So
I got x minus 1 squared, and then plus y squared equals to 1, and it's an ellipse.
So that is the right answer. Question number 14 is similar to that question. So the question here is, we need to convert the equation r equals 8 sine theta to a standard form of an ellipse, of a conic section, and then we need to determine whether it's an ellipse or any other of the conic sections provided here, ellipse, hyperbola, parabola, or not a conic. So r equals 8 sine theta. I'm going to go to my notes here. So the equation here is r equals to 8 sine theta. Similar to what I did before, I'm going to multiply both sides by r. So I have r squared equals 8r sine theta. The reason we multiply by r is because we need r sine theta or r cosine theta in order to convert that into y or x. We know that r sine theta is basically y. So y equals r sine theta. And we know that r squared is equal to x squared plus y squared. So we're going to replace these back in here. So x squared plus y squared placing it in this equation, equals 8y. I'm going to make this side equal to 0, so I'm going to subtract 8y from this side, and I'm going to subtract 8y from that side. These are going to cancel. I will have 0, and I will have x squared plus y squared minus 8y equals 0. Again, this is complete squared. I don't need to do anything about that. These two terms need to be completed. We need to complete the square for those two terms. So I'm going to take the negative 8 divided by 2 and square it, which is going to give me negative 4 squared, and that is basically 16. So I'm going to add 16 to both sides of the equation. X squared plus y squared minus 8y plus 16 equals 0 plus 16 is 16. Now, this term, this expression can be factored, so x squared plus y minus 4 all squared equals 16. Now I need this side to be 1, so I'm going to divide every term by 16 to make it into the standard form of the conic section. Here, x squared over 16 plus y minus 4 all squared divided by 16 equals 1. So this is an ellipse. I'm going to plug my answers to the equation here. So I have
x squared over 16 plus y minus 4 all squared over 16 equals 1. And this is an ellipse.
This is how you're going to answer question number 13 and question number 14.